Hello friends, this video on States of Matter Part 5 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched Part 1 to Part 4. Now let's talk about thermal energy. So what is thermal energy? So if you see, thermal energy is nothing but energy of a body arising from the motion of its atom or molecule. So I have, let's suppose the jar, I have so many molecules, or I can take about atoms. So they're just moving around, right? They're just jumping and pumping around. So due to this, we get thermal energy. So when I say thermal energy is more, that means the jumping and pumping is more. It will jump at the fast speed. Saying thermal energy is less, that means it is moving at a lower speed. So if we talk about, let's suppose you have ice and you have water vapors. So if you see in ice, these molecules will be moving at a slow pace. But if you talk about vapors, these molecules or atoms will be moving at a higher pace. And that's how you define thermal energy. You say that my water or vapors have higher thermal energy than ice, because in the ice, these molecules, they move at slower pace. Or if we talk about a hot place, for example, Sahara Desert, and a very cold place, let's say Greenwich Island, a very cold place, Kashmir or something. So there also, if you talk about the hot place, the molecules all around the hot place will be traveling they'll be moving around the higher speed. And the molecules in the cold place, they'll be moving around in a slower pace. So thermal energy is all decided by this thing, how fast or how slow this molecule is. Correct? So if you see, as I told, right, if it is my ice and if it is my water, so in case of ice, my molecules move at a very slow pace. Water, it will move at a higher speed. Correct? So as I told, this is directly proportional to the temperature of the substance. The thermal energy, the name itself comes from thermal, temperature. Thermal energy is directly proportional to the temperature of the substance, because the higher the temperature is, the faster this atoms or molecules will move. Right? So in another way, you can say that this thermal energy is nothing but it's a measure of average kinetic energy of the particles. Right? So this thermal energy is nothing but average kinetic energy. If I say thermal energy of this is x and water is x plus y, that means I can say that x kinetic energy is proportional to x and water kinetic energy is proportional to x plus y. So the thermal energy is directly proportional to the kinetic energy, directly proportional to the temperature of the substance. Right? And this movement of particle is called thermal motion. This particle movement is called what? Thermal motion. So what we have learned? Thermal energy is more about the kinetic energy of the particle. It's directly proportional to temperature. You increase the temperature, the thermal energy increase, the kinetic energy also increase. This motion is called thermal motion. Let's discuss the intermolecular force and thermal energy. Actually, both are rival. Both are rival. This guy tries to bind everybody, bind the molecules, and this guy wants to chase away the molecules actually. I'll show you this. So if you see, the intermolecular force, they try to bind the molecules together. They want to keep the molecules together like this. So you can say that these guys are intermolecular force. Some force which is this lady is a force between these two, right? Maybe a sister. So this sister is trying to bind these two brothers. So see this intermolecular force between these two, right? So intermolecular force is someone which tries to bind the molecules together. But this thermal energy, you want to keep them apart, right? This guy want to keep these two apart. So this guy is my thermal energy. Correct? So intermolecular force is something which tries to bind it, and thermal energy is something which tries to keep them apart. So there's a fight between this and this. Right? The fight between thermal energy and intermolecular force, and this equilibrium decides whether my matter will be solid, liquid or gas. Correct? So if you see, three states of matter is a result of equilibrium between these two. So if my intermolecular force is more and thermal energy is weak, my substance is solid. It's almost equal kind, it will be liquid. And if my thermal energy wins, it is more, then it will be all gas. Because thermal energy wins, all these particles will be apart, will be moving around and become gas. In this case, if my thermal energy is weak and my intermolecular force is strong, they'll be totally binded and they'll be solid. You can, you can relate the whole chemistry and these chapters with your real life, right? If you're strong together, you're united, you are solid. Nobody can break you. If you're all apart, you're gas. You don't have identity. So you can all relate things with your real life, the way the chemical reacts, all this, as I told, right? The energy is like a stress. People want to lose stress, and the atoms, they want to lose stress to become molecules. Once they are molecules, they again have this intermolecular force come into picture, and they try to be united. And then we have something called thermal energy also comes into picture. We try to keep them apart, and there's a fight between them going on. So if my intermolecular energy force wins, it becomes solid. If this thermal guy wins, it becomes gas, and if it is an equal kind, it becomes liquid. So you can relate everything with a story actually, or the whole chemistry. You can think of a story and the real life scenarios actually.
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.